What is classic computers about? How classic computers works? Computers we use works. We are giving input and computer is processing it in the form of 0 or 1. Okay, that is a binary bits. That is, even if we are giving input in our own language, for example, English to computers, computer process it as either 0 or 1. And that is whether it has electricity or not. 0 or 1. This is the classical form how computers are processing the information or the input we are giving. Okay, this is what classical computers does. But when we look at the level of quantum level or the smallest size, the difference is the processing in the processing of the information. Okay, so here we said that classical computers use bits in for processing, either 0 or 1. That is the or 1. That is the most important part to be remembered. Okay, quantum computers use logical units called quantum bits or qubits. Okay, this is the part or logical units which are used by quantum computers. Okay, what is the difference between classical computing and quantum computing is when we said classical computers use a 0 or 1 for its transmission. Here, quantum bits or quantum computers use 0 and 1 simultaneously. Okay, that is the major difference. Here, when we see the classical computers, it uses either 0 or 1. But when we see quantum computers, it uses 0 and 1 simultaneously. Okay, and the unit is of quantum computer is quantum bits or qubits. Clear with this? Now, two of the important principles in quantum computing is superpositioning and quantum entanglement. Just know that superpositioning and quantum entanglement or entanglement is related to the quantum computing. Okay, superposition is what we just discussed now. That is, the quantum bit stays or in the form of 0 and 1 simultaneously. Okay, that is superpositioning. The principle of superpositioning says that each quantum bit or information represent both 0 and 1 at the same time. Okay. Now, entanglement is another property of or another principle of quantum computing. Here it says that see, for example, it can also be represented in the form of electronic level. Okay. So if we say the electron can spin either this direction or this direction. That is in the upward direction or downward direction. Okay, togetherly. If we say in according to the principle of superposition means it will have upward and downward movement at the same time. Okay, clear? If we say movement of electron according to superposition principle, it can have upward and downward spin at the same time. Okay, so that is something which we see according to superposition. Okay, but when we see separately, okay, when two electrons are together, we can have or we can arrange it, say it and according to the superposition principle. But if we take away these two electrons away from each other, if this shows this spin, meaning alternatively the other will be having this spin, right? Clear with this? If we individually look at each one of them, if one of them is having this downward spin, means the other one will be having upward spin. Clear? Okay. So this will stay accordingly even if we take in the other part of the world. Like for now, I am having two electrons and one I see I am having the one with downward spin. So you are taking the other electron part to, say, for example, Australia. Then when you see it from there, the one which you had will be having the upward spin, opposite spin, right? So this means that even if they are distances or separated across in various distances, we can see that one electron spin depends on the other one, right? So this is entanglement. Subatomic particles become entangled in such a way that any change in one disturbs the other even if both are at opposite end of the universe. Clear? These are the principles according to which quantum computers works. First, we said two principles. One is superpositioning and the other one is entanglement. Superpositioning means that it can have both 0 and 1 or upward or downward spin in case of electrons at the same simultaneously. Okay, quantum entanglement means any change in one will disturb or will bring change into the other particle even if they are placed in at many distances far apart. Okay, so what is the application of quantum entanglement? That is the next one. Okay, before that, quantum supremacy. A state when a quantum device can solve a problem that no classical computer can solve in any feasible amount of time, irrespective of the usefulness of the problem. This is quantum supremacy. Quantum supremacy means the higher ability of the quantum computers or the higher ability. It says that it can solve problems, that is maths problems or mathematical formulas, even when the classical computer can't solve it. Okay, this means that quantum supremacy, quantum devices are that much efficient to solve the problems in a feasible amount of time or less amount of time compared to that of the classical computers. If classical computers need 10,000 years, this quantum computers can solve within 2200 seconds. Okay, that much efficiency is there in quantum supremacy or quantum computers. Clear? Okay, you have heard of encryption, right? What do you mean by encryption? Encrypted form? Yes, that will be in a translated to a code, and then if we only that code, we will be able to identify or decode what the message is, right? So usually what happens is, if we send a message, for example, hi to someone, okay, it will be translated into a mathematical formula, for example, XYZ. Okay, this is what happens. And when it reaches the receiver's form, it will reach as XYZ only. Then it gets converted into hi message. This is normally what happens in encryption, right? So when a third party breaches into it, what he will see is, he will see XYZ, right? We have heard about like hacking, etc. Right, reading our messages by third party, etc. Right? This is normally happens when the encryption or the process of efficiency is considered. Okay, but what happens in quantum computing is there will be a satellite. Okay, satellite. It will send. We have to send a message from this point to the. We have to send message from this point to this point. Okay. So there will be a satellite and they will send two particles. What will be its properties? What will be its properties? What are the principles according to which? Superpositioning. Remember, superpositioning means the particles will have simultaneous spin, both upward and now downward. Okay. So it will send the same particles to the receiver. Okay. To the receiver. So this will be in superpositioned form, right? But when a third party intrudes or tries to look upon the message, then there will be a change in the superpositioning. Either it will be positive or either will be negative. Okay, so if this happens only when a third party intrudes or tries to get our messages. Okay, this means that this will allow the authorities to check whether there is a breachment or a hacking happened. Clear? We have to send a message from A to B. We are sending a message and there is a satellite and it uses quantum dots or quantum technology for it. And it will send particles. The particles will be in superpositioned form. Okay. And it will reach the receiver. There is no other entity involved. So even though superposition form, the receiver can actually trace what is or see what is the information is. This is between the sender and the receiver. That's only the they are only the two parties involved in the sending messages. No one is involved. Okay, so no mathematical formula is also involved like that of the encryption. But when a third party tries to intrude in the message or try to see what the message is, the superposition form gets disrupted and there will be entangled form. Entangled form means they will be either positive or either negative. Either will be having upward spin or negative spin, downward spin. So this means that there is an intrusion by a third party. Okay, so that means that this allows secure communication, right? When the particle or electrons changes or the electron spinning is changed in the communication system means there is a breach from outside. If there is no breach means no superposition change. Okay, so this means that it allows secure communication. So we can say that compared to classical computing, quantum computing is more secure. So it allows more secure communication and faster communication as well. Clear? Okay. We even talked about quantum supremacy, right? In quantum supremacy, what happens? Classical computing, if the computer can solve within many days, it will solve within seconds. Okay, so the first most important advantage is speed. Okay, next advantage is we only need less storage. Why? Because it will exist as 0 and 1 simultaneously, right? In the classical computing, 0 will be stored in one file and 1 will be stored in the different file. Here, superpositioning means they will be stored together. So less space is needed. Next one is simulation. We can use this for simulating the weather arena, for chemical stimulation, etc. We can identify or we can create simulate similar environment for identifying the weather forecasting, chemical simulation, etc. Okay. Next one is privacy. Privacy is what we discussed just now. When a third party intrudes means we will identify that immediately because there will be a change in the spin of the particles. The particles will change from superposition to entangled form. Impossible to break the security of quantum entanglement-based cryptography. Clear? So, applications. I have just listed some of the applications. Only it's like first thing you want to know is like if it is a communication or an emerging technology topic means it will have a wider arena of applications. Okay, I just listed 2 or 3. It is not like that. You can even, I listed secure communication, research, agriculture. You can list what are health, even social development. Then what all? Yes, defense purposes, to improve efficiency. See, in every applications or when we consider the technology as such, it should be or we should identify that it will have wider applications in wider arena. Okay, so this was about quantum computing or quantum supremacy. Clear?